Assalamualaikum and a very good evening to everyone. My name is Nur Azima binti Zamri, lecturer from Faculty of Engineering and Bioenvironment, Masa University. Along with me is TS Dr. Nurul Wahida binti Kamaru Zaman from IUKL. Dr. Nurul Wahida, can you introduce yourself?
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Nuazima, for having me here today. My name is Nurul Wahida binti Kamaru Zaman. I am currently working at Infrastructure University Kuala Lumpur, UKL. I think for 2 years now after I graduated my PhD. Thank you for having me today to share the knowledge regarding to the topic, which is on the sustainable and green materials in construction.
Thank you, Doctor. We are so happy for you to be here. And actually,
Me too.
Doctor is also one of my colleagues. We haven't seen for like 3 years, right? So
Yeah,
long.
I think so.
3 years we haven't seen each other. So today, for the audience information, we are going to our webinar is going to talk on the green technology, and and also the impacts towards the Malaysian economics. Okay, so actually we are going to focus on the palm oil, concrete palm oil on the concrete application. And and we know that currently the green technology has become one of the trending during the construction material, because of we are currently our natural resources such as the coarse aggregate, the granites, the sand from the river sand and so on keep on depleting due to the quarrying and also the bombing, because of we need to take the materials, the sand and also the coarse aggregate to be used inside the concrete. Okay, so this is an example of the rock quarrying and also the sand mining. Okay, so we can see that because of the rock quarrying and also the sand mining, it will disturb our ecosystem and also the wildlife. They will lose their places to live, and then also it will contribute towards the pollution such as the river pollution, water pollution, air pollution, soil pollution, and so on. Right. Okay, so these are the impact of sand mining and also rock quarrying, the ground pollution, the air pollution, water pollution, loss of wildlife, and so on. Okay.
All right. As you can see from the picture here, most of us already probably knows. Yeah, this is a palm oil tree that generates billions, yeah, of ringgit in our country, in Malaysia. So it is also known as the second largest palm oil production after Indonesia. Yeah. Next, please. For those who already know, yeah, apart from producing palm oil for cooking, baking, and so on, it is also used in the production of cosmetics, cleaning products, shampoo, and many more. Yeah, thanks. And
however, most of people don't know that apart from all those products just now, this palm oil waste, this palm oil can also be used as a construction, as a replacement for the construction material. How and is it possible? Yes, I will show you on how is it possible to replace our material. Okay, and as for your information, Malaysian is our the second largest, as told by TS Dr. Nurul Wahida just now. Malaysia is the second largest producer of the palm oil in the world. Okay, second highest producer. So because of that, we produce so many tons, million tons of waste, and this waste we have done some research, and it is possible because and this waste has a huge potential to be used as a replacement inside the concrete. Okay, so these are the example of waste that can be after we extract the oil from the oil from this tree, we are going to get a few waste, a few types of waste, a lot of waste actually, but these are the three example of waste that can be utilized inside the production of material, construction material. The first one is the oil palm shell. The second one is palm oil clinker that looks like looks like a stone here. And then the third one is the palm oil ash. Okay, this palm oil shell, you can get it after you take you take out the oil, then you can take. They are going to extract using the machine. And the second one, which is the palm oil clinker, this palm oil clinker is actually produced by the incineration of the empty fruit bunch. Okay, once they burn this empty fruit bunch, it will produce a stone-like waste. We call it as the palm oil clinker. This palm oil clinker is very hard and very strong. So we have done some research, and we can see that kind of this kind of stone can actually replace our natural coarse granite aggregate. Okay. Also,
Yes, but only partial, right?
yeah, no, for the coarse aggregate, we can replace 100%, and same goes to the oil palm shell. Only that the cement, the POFA, the palm oil ash only, we couldn't find a way to replace it 100% because of um, it doesn't have the what we call it, the properties is not 100% like cement. It is a
Mm-hmm.
pozzolanic material, and this pozzolanic material is actually it need to react with the calcium hydroxide inside the cement itself. Then only it can produce the calcium silicate hydrate gel that will bound to get together all those material inside the concrete. So we can use 100%. I think according to my readings, I think some researchers can go up to 60% only replacement of POFA, right?
Mm-hmm.
So this is oil palm shell. Okay, so oil palm shell, you can see this one, the chocolate color here. So you can see this palm oil shell. Okay, we already done the research, done the observation and testing and so on. This oil palm shell has the almost the same properties like a wood. Okay, so we know that wood has been used as a material to build a houses also. So this oil palm shell also can be used to replace 100% aggregate inside the concrete. And for those who don't know what is concrete is actually a combination between is a mixture of coarse aggregate, sand, cement, and also water. Okay, so this thing, if we mix together, it will produce a concrete, which is very hard. Okay, very high strength. Due to that, people love to use concrete because of it is the strength. You can design the strength up to how many hundreds megapascal and so on, and also it is versatile, and it is easy for us to remold the concrete. That means if let's say you want to make a concrete which is like rectangle, so you can just build a mold, and then you just pour the concrete inside the mold, so it will follow the shape of the mold and so on. If you want to make it triangle, just make a mold which is triangle in shape, then you just pour the concrete, then it will become triangle. So that is why people love this concrete. And also this concrete is very high durable. That means it has a very high durability towards sulfate, towards acid, and so on. So this is the different. This is concrete, and I think most people are confused between concrete, mortar, and also paste. Actually, concrete is combination of coarse aggregate, sand, cement, and also water. But for mortar is the combination of sand, cement, and also water. Mortar don't have you don't have a coarse aggregate inside its mixture. And for paste only have water and also cement only. So that is actually the difference between concrete, mortar, and also paste. And I see that a lot of uncle, auntie, they usually say that this one is made of cement. They actually don't know what is the real term of this concrete. All right. So I hope that you get something from here. Correct. Another one is the just now is oil palm shell. Now we is palm oil clinker. This palm oil clinker, it can be used to replace both sand and also coarse aggregate. If let's say we want to replace sand, that means we have to crush this clinker to become smaller. Then only we can you can replace the sand. So if you want to replace coarse aggregate, that means you have to crush until certain sizes. Okay, let's say passing 10 millimeter and retain 5 millimeter, then only you can use as a replacement for the coarse aggregate. All right. Okay, and this another one is the palm oil ash. All right, we call it palm oil fuel ash. The researcher call it as palm oil fuel ash. I'm not sure why they call it fuel ash, but this is the term that we use. But usually we call it as palm oil ash only. So this palm oil ash also came from the burning of the empty fruit bunch, but the temperature is much more higher, like 3000 degrees Celsius something, and then it will produce this ashes, which is gray in color. This ashes is has a very high pozzolanic reaction, so it
Question.
can, yeah, the reaction so it can use to replace a partially replace a cement. So this thing can only replace partially lah the cement. So now people are currently trying to find the sources. I mean, trying to find whatever things that is similar like this POFA to replace the cement, because we know that if you want to take the cement, you have to slaughter our hill. You know, we have to crush, we have to destroy the hill, then we have to crush. So we, because of that, we are going to destroy the ecosystem. So now we are trying hard to find what can we do to replace the cement, right? All right. So these are the findings from the previous research. So actually, not only us do this research. Okay, a lot of people have done, but they are doing in the in the different different types of concrete. So in 2004, we have Manan, okay, from UTM. He already, I think he's the first one who figure out this, like this oil palm shell. He used this oil palm shell to replace aggregate inside the lightweight aggregate concrete, and then 2013, from USM, I think Alengaram, he replaced in the firm concrete, and then Alengaram also replaced oil palm shell in the geopolymer lightweight concrete. Same goes to the palm oil shell. It has been used in the replacement of cement partially inside the high strength concrete, and then in aerated concrete, firm concrete, as well as geopolymer concrete, right? And also for the palm oil clinker also has been used before. They use it as a coarse aggregate replacement, and also sand aggregate replacement to produce beams, high strength lightweight concrete. For the palm oil clinker, usually it can produce a very high strength concrete, which is a good potential to be used in the production of a usually this high strength concrete we are going to build, we are going to use it inside the construction of what we call it, the bridges, the high rise building. Okay, so we can use this high strength concrete. So these are the previous research that we have done. All right. So last time, um, what makes us different from the rest of the researchers is that we combine this oil palm shell and also POFA inside the research. Okay, inside our research, we combine the oil palm shell and also the POFA, okay, which is the palm oil ash, and then we produce this kind of concrete. All right. So and this, if you want to, let's say you have the intention to try, okay, so these are the material that we have been used. So we need cement, we have sand, okay, and then the oil palm shell, the POFA, water, and also we add on some super plasticizer, because of lightweight aggregate concrete is consume a lot of water, so we have to make sure that we didn't use too much water. So we have to add on either admixture or the super plasticizer to balance the water, right? And also, if you want to use this oil palm shell, you cannot simply take it and replace it inside this what we call this material inside the concrete. you have to do some processing. Okay, so upon taking the sample from the factory, first you have to wash the oil palm shell, because we know that this is a organic material. So sometimes there will be impurity, sometimes there are some insects, so you have to like wash it first. After that you have to dry it, okay, until it reached SSD, which is saturated surface dry condition. After that you have to crush it, okay, using the jaw crusher. And then you have to until certain sizes has been achieved, right? Then only you can use it inside your concrete, right? And then for the palm oil flue ash, upon taking from the factory, you have to sieve using the sieve. You have to sieve passing 300 micrometer, okay, and then you have to grind, okay, using the last time I used Los Angeles abrasion machine, but this one is a big scale of it, quite big. And we like cycle, we do cycle for about 30,000 cycle, which takes around 1 week, one whole week to cycle to use it for 30,000 cycle. So it takes like 1 week for like 2 kg of sample to grind. And then after that you have to sieve using the sieve of passing 45 micrometer. If we find figure out that after we grind for like 30,000 cycle, the sample, the particle become very small, which is passing 45 micrometer, in order to increase the pozzolanic reactivity inside the POFA, inside the ashes. Okay, so we need the high at least type F pozzolanic material, then only we can put inside the inside this concrete lah. Okay, actually we need to do a lot of testing and so on, but that one later on lah we will discuss, right? So after that we can start you can start to mix, okay, just mix like what we have mixed before, and then we test using the compressive strength test in order to find the strength of the concrete. Okay, so from our findings, we figure out that these three has the highest result, which is from 10% to 30%. We do like from 0 to 50%. Zero, that means the OPS concrete without any POFA, and then 50% is until 50% replacement. So we can see that these three produce the highest strength. And then we can also see here that 40% and 50%, at 40% and 50%, it shows the data becomes become decreased, the strength is decreased. And we also figure out that 50% is not suitable to be used inside to replace the cement, because of when the pozzolanic material is higher, it cannot react with the lower amount of cement, because in pozzolanic material there will be this pozzolanic material is actually going to react with the cement, calcium hydroxide inside the cement, and produce CSH gel. This CSH gel is like a glue to bind together all those things. But if let's say the pozzolanic material is too high, then the cement is too low, then they cannot bind together. Okay, so that means 50% is not that is not suitable, because of we can see here the strength becomes lower than 25%, 25 megapascal, right? So most of our building in Malaysia, we have to reach 30 megapascal for structural buildings. Okay, and then the best replacement is 20%. So we recommend 20% of palm oil ash inside the oil palm shell concrete, right? This is for the oil palm shell. And also for the practical application, we recommend to use for the non-structural element, such as the curb, although the strength is like 30 megapascal above, but we recommend for non-structural members, that doesn't need any doesn't have any loading on top of it, such as the curb, the pavement, and also the drain cover. Okay, actually some of the researcher even already they even built a house using the oil palm shell concrete. Okay, so this is for the oil palm shell. Now let us go to the palm oil clinker. Okay, just now is palm oil shell plus with POFA. Now is palm oil clinker plus with the POFA. So this palm oil clinker also will use will use as a partial not partial, 100% replacement to replace coarse aggregate inside the concrete, and also POFA as partial replacement inside the concrete. Alright. So it will produce the same thing, which is the concrete. So these are the materials. So the same thing like the oil palm shell just now. We just replace this one with the palm oil clinker. Alright. And the same thing also, you have to process the palm oil clinker. We cannot simply put it inside the we cannot simply replace, okay, because the it is big actually. It's in a big chunk of rock. So what you have to do is you have to first, when you take the sample, you have to wash it first, because there will be some fiber, okay, inside the not inside around the clinker, and this fiber, if you mix together, it will absorb a lot of water. So you have to clean it first. You have to like wash, okay. After you wash, you have to oven dry, okay, until SSD. After that, you have to crush, okay, this palm oil clinker, because so that it become a smaller particle. Okay, for me last time I crush and then I sieve using 10 millimeter sieve. Whatever passing 10 millimeter sieve and retain at 5 millimeter, I'm going to take it and replace inside my concrete. All right. And for the palm oil fuel ash also, I use the same method like the one I use for the oil palm shell. Okay, you have to oven dry, and then you have to sieve using 300 micrometer sieve, and then you have to grind for 30,000 cycle. Then only you can use, right? So these are the result that we managed to get from the palm oil clinker research. Okay, we can see it's quite different. It's a little bit different from the result, which is from the oil palm shell. So we can see that the compressive strength is much more higher. You can see just now it's like 30 something, but for the palm oil clinker, it is high strength concrete, which is around 60. We target the strength is like 60 megapascal, which and this 60 megapascal is suitable for the construction of the like flyover, like bridges, like high-rise building. Okay, and also for the palm oil, for the palm oil ash, we observe that 10% is the best replacement for the POFA inside the palm oil clinker concrete. Alright, so the different for the oil palm shell, we managed to get 20%, but for the palm oil clinker, we managed to get only 10% only, right? And then also, what we figure out that the cement, when we put palm oil ash inside the palm oil clinker concrete, we figure out that the cement paste. This is the ITZ, right? Interfacial zone. We use high definition microscope. We can see that the cement paste perfectly merge with the aggregate when we add the ash inside this concrete. Okay, so it is quite smooth lah, right? So these are the what we figure out from our research. Okay, so what we figure out is that what is actually the importance of this research. Okay, so first, for sure, we are going to give you the audience the awareness on why we supposed to preserve our natural resources, because of our natural resources keep on depleting. So we have to as a human, we have to try our best to preserve our natural resources. All right. And also, we have to try our best to reduce the waste disposed by the industries. Okay, if too much waste, that means it will cause a lot of pollution, and also the country have to pay a lot of money, okay, in order to find a place to dump all this waste material, right? And also, okay, we can if we know that the cement production will produce high number of carbon dioxide. So by utilizing the POFA, we can help to reduce the carbon dioxide emission that is produced from the cement industry. And who knows, maybe after this, later on, Malaysia can start to export the waste, okay, from our palm oil, that will also help to generate our Malaysian economy. Okay, who knows? Right. So that is the end of my set. I think that maybe Dr. Nurul Wahida can what we call that share, because Dr. Nurul Wahida also he's one of the expert, the best has a high expertise in green building. Maybe you can and as far as what I know, she is the first the first, I think one of the first person that use laterite inside the utilization, inside the concrete technology. Is it, Dr. Wahida? Can you like share with us some of your research on laterite, please?
All right, of course, Dr. Azima, thank you. Actually, when we are talking about the green materials, yeah, we are looking into something that contributing to our environment. Yeah, it must be not giving bad effect towards environment in terms of the production, installation, even maintenance. Yeah, so that's why we are looking into several materials now that we are going to replace in our concrete productions, where we are looking into uh, what we call materials that easily compose, that can be renewed, yeah, and able to prevent any negative impacts towards environments. So what is bad or negative impact towards the environment? It is the impact that we considered um, can endanger or disturb the ecosystem of our world, yeah, even globally, yeah. So talking about that, that material supposed to be having like very long in term of the life cycle, and also in term of the serviceability. So this is what we are going to look into in in near future. We try to find out what is the green materials that really suit in order for us to use in concrete production. Yeah, in Malaysia, uh, this kind of material, yeah, need to be declared. Yeah, why it needs to be declared? Because nowadays, yeah, Malaysia is moving towards the green, what we call it, the green technology in construction. So they have one terms that's called that's been called EPD, Environmental Product Declaration, where all the product must be declared, yeah, even before being manufactured, yeah. So it is to ensure that this particular specification will be distributed, and all the users will know about it. Yeah, so they are actually knows what is the updated, or what is the latest specification of that material, because we know back then, maybe 10-20 years back, okay, that material is okay during that time, but after doing or after conducting several research, okay, we know that this will endanger our environment, so that material need to be stopped in term of the production, in term of the usage. Yeah, so that's why the declaration is important nowadays. So one of the material that I was looking into, I think several years ago, because, and also it's still ongoing, yeah, because now I am maybe 80% of doing this, because I need to make sure this material is really, really can be used, and it has the strength that we need, and also at the same time it can deliver a good quality material, yeah, in terms of the concrete, yeah. Okay, you see here we have laterite aggregate, yeah. You see it's really common, right? It's common material in Malaysia. You can see it by roadside. You can see it next to your house even, you know. So by looking at this picture, you can see it has various color, right? It can be orangish, it can be reddish or brownish, depending on the level of the weathering process. Because how this laterite aggregate being produced is actually being produced by the process that what we call weathering process. Yeah, because in a tropical region we have high rainfall, high number of rainfall, and also we have a sunlight, very optimum sunlight. So this process will continuously produce this laterite aggregate. That's what you see. They have difference in terms of the color, where the brownish, yeah, the darker color will will indicate stronger lah, because they have like longer weathering process. Yeah. And you see about the size and texture also, they have different also, because this is naturally produced. Yeah. In terms of the size, yeah, they're small, they're even produced as big as a rock, yeah, as a stone. Yeah. So it depends on the weathering level at that time, and also the texture. Some will have like round texture or smooth texture, and then some will have like very rough surface, very edgy, and have sharp edges. So this kind of material, we need to really identify, yeah, what is the type. Even it is in the same group, laterite aggregate, we need to really identify what kind of color that's suitable to be used, yeah, what kind of texture, what kind of size that really suit into concrete production. Yeah. So you can see, even around you, you can see there's so many laterite aggregate that really abundantly, yeah, it's abundantly available, and we can use it. Yeah, we can use it in order for us to lower down the level of the blasting work in the quarry. So like Dr. Azimah said just now, it's really disturbing, right now, because it's going to make that our natural resources will going to have depletion very, very soon. So it's really crucial for us, the researchers, in order to find out what is the new material that can sustain the environmental and also the ecosystem level in general. Yeah. So I've done several research, yeah, in terms of the engineering properties, and also in terms of the durability or serviceability of this material. Yeah. If you see here, I've conducted three kind of tests, where it shows on the compressive strength, flexural strength, and modulus of elasticity of the concrete that makes from the laterite aggregate. I think during this time, I use various kind of percentage, yeah, in terms of the replacement, where I use 10, 20, 30, 40, and 50 to see what is the trend of this replacement percentage. Yeah. So during that time, yeah, I've used this replacement, yeah, as the alternative material. Yeah, I've compared the laterite and also the granite, which will be which was my control specimen at that time. Yeah. So after conducted these three compressive strength, flexural strength, and modulus of elasticity tests, so what I can conclude that this material, yeah, this material up to 30%, it is able to attain significant strength that we need, that we already designed at that time. So it means that it can be used in concrete mix, but only at certain replacement, which is during that time at 30%. So it was a happy moment for me, yeah, because I found something that really can help our industry, and able to lower down the usage of the natural resource. Yeah. And if you see there, when I compare with the control specimen, yeah, the standard deviation is lesser than 5%. It's even better, when we are talking about the standard deviation, it's really important for us to know whether the data set is belong to that group or not. Yeah. When it has the standard deviation lower than 5%, it means that it's belong to the group, meaning that it has similarity with the control specimen. So it was a happy moment for me lah, yeah. So if you see the first picture is showing the compressive strength, yeah, of the laterite concrete. If you see, even the failure behavior is similar to the control, yeah, because we want to have a shape like a woman, like a woman shape. So it shows that the shear failure is happen, yeah, at the center of it, because we can see it is weaker at the tension pipe. Yeah, and also I've conducted durability performance, yeah, test. Okay, I was thinking, what if this concrete were exposed to the extreme environment. We know that our soil, yeah, in Malaysia, even around the world, it has different chemical composition inside it. So what if this laterite concrete been used in the acidic or sulfate condition, yeah, in terms of the soil. So I've conducted several tests. This is what I got in terms of the results, yeah. If you see the first picture shows that there's some detachment, yeah, because it's already been exposed to the acid attack, yeah, for like 1,800 hours continuously. And based on this detachment also, yeah, it actually contribute to the strength loss, yeah, because it's not solid anymore. And then when you compress it, when you test upon compressive strength, it shows the loss in term of the strength, yeah. So and based on this acid attack experiment also, yeah, if you see the bottom picture, there are two of them. The first one is in the beginning of the test, yeah, and the next to it is the picture at the end of the test. Yeah, if you see there are some changes in terms of the color. Yeah, the crystal clear water will actually change to the yellowish color. This is due to the reaction, yeah, between the cement composition with the chloride. Yeah, so it's actually having some reaction, and then it's changed the color of the solution, yeah, towards to the yellowish. Yeah, in terms of the sulfate, yeah, in terms of the sulfate is actually kind of good, yeah, because I think the weathering process itself already helped the laterite aggregate to actually sustain several attack, yeah, during the service. So that's why during the sulfate attack there are some expansion also, but the strength loss is below 5% in terms of the standard deviation is really good, yeah. In terms of the um, conclusion, yeah, because I've done these two durability tests. So I've come to the conclusion in terms of the acid and sulfate attack, where the performance is very good, yeah, and also have the similarity to the control specimen, because I already do the statistical analysis also, and it shows that the standard deviation percentage is 5% and lower, yeah, depending on the specimen that I test, yeah. And it was a happy moment for me too, yeah, in terms of the durability performances. All right, based on this research, yeah, what I can conclude that it's really critical for us, yeah, the researchers, to find out what is the material that we can use in the concrete production in order for us to limit or to reduce the usage of the natural natural resource such as granite, limestone. All these kind of materials need to undergo several what we call several blasting work lah, yeah. They need to be blast, and then they need to come up with the what we call with the several process, yeah, at the quarry. They need to crash it, they need to sieve, and then you crash it again, regarding to the particle size that being ordered by the manufacturer, yeah. So it's really harmful, and also endanger to the environment, yeah. It's really important for us to minimize the usage of the natural resource, for us to tackle this depletion issue, as mentioned by Dr. Nur Azimah just now, yeah. And also I hope for the students, yeah, especially in civil engineering, we actually can do more research in finding what are the suitable material that we can investigate to fit into the green and sustainable concrete making. Yeah, because um, we are we are the person that going to give a better tomorrow for our nation. Yeah, I think that's all from me, Dr. Azima.
Thank you, Dr. Nurul Wahida, for that informative concrete green material. Okay, and Dr. Wahida, as for your information, I am from Perak, and whenever I went back to my hometown in Perak, let's say I went back last time, in Gopeng area especially, if we go to Gopeng area, we can see that there are a lot of hill. They already like bomb the whole hill, and then when I came back the next year, the hill become half. Okay, I think I didn't go back since this COVID. I didn't go back like 1 year. I think when I go back this time, I think the hill there will be no more hills because of they keep on
Yeah.
digging. Yeah, they keep on quarrying, and then and we know
Yes.
that in Perak, in my hometown, okay, in my hometown, most of the hill we use as the tourism places. So I think
Mm.
what will happen today, I guess, like what will happen later on if we don't have any hills anymore, so they will affect our tourism as well as our Malaysian, because tourism also generates a lot of money to Malaysia.
Yes. Yes.
So I
Yes.
think it will also affect our economy as well, is it?
Yes,
So I
yes,
think
that's for sure, Dr. Nazima, because
yeah.
it's
So
really sad, right, to see
mm,
what we did to our nature, right? We need to
yeah.
preserve it. Instead of preserve it, we are ruining it. You know, it's really shameful actually to the mankind because we need to preserve what we have.
Yeah.
Even in Pahang, because I'm from Pahang, we
Uh,
did so many quarrying, even near to my house, near to my mother's house, my parents' house. They have several quarries there. That's
is it is it is it granite or is it bauxite?
was it in Kuantan. But at
Oh,
that
it's
time, I was I was doing some research also during my diploma. With My mother and I was going to that to that quarry near to my house, and then we actually come up with this conclusion that later in very near future we are not going to see any hills anymore in my
yeah.
hometown, because yeah, it's same to your situation actually. I think it's happening in each state, I think. Even
Yes,
even
yes,
even globally, right? Even globally.
yes.
So
Mm-hmm.
it's really sad and also shameful to the mankind if we not preserve what we have. Yeah? And also we need to really make it happen lah. Yeah, it's supposed to be it's supposed to be a combination of the research in term of the academic area and also in term of the industry, the real practice. Yeah,
Yes,
because
yes, yes.
what I can observe here is that our research is finished at one point, and then
Yes,
it is not being conducted in the real practice. Yeah, it is
yeah.
kind of waste lah, yeah, because we invest a lot of money there and energy and effort, yeah, to make it happen. So
Yes.
I really hope we can actually develop this alternative material together with all the data set, and then we present it to the ministry, who knows, right, in near future
CID.
maybe. Yeah.
I think CID
Yes,
also going for the green building right now, but just that
yes,
the
yes.
research is not they didn't reach that kind of level. So
Hmm.
that means that people still not going to apply inside the conventional construction. So we hope that one day, I
Yes.
don't, not one day, they have to do it as soon as possible before we lost everything, right?
Yes, even now we are being hit by the pandemic very hard, right?
Yes.
It's really difficult for us to sustain our construction industry
Yes.
unless we do some revision in term of the cost, yeah, in term of the effective cost. This effective cost is actually one of the elements here is the material itself. So once we use the the abundantly available or the waste material like yours, it's really helpful in terms of the finding the effective way in reducing the construction costs. Even it's not suitable for the high load bearing, we can use it for the non load bearing wall, maybe for the apron, for
Yeah.
the fencing.
Mm.
There's so many usage out there that we can implement. This usage of the alternative material, not supposed to finish on the shelf, on the thesis shelf.
Yes,
That's
yes.
my opinion, my
Mm.
honest opinion. I really hope we can change it somehow, one
We
day.
have to. We have to.
The people like
Okay.
us need to
Yeah.
do it.
Yeah. Okay, Dr. Nura Wahida, thank you so much for coming today.
Thank you also for having me.
I'm really glad that you are with me today. I have partner at
Yeah.
least. Okay. So we hope that later on we can collaborate. And who knows that we can do research together next time? Who knows? We
Yeah,
can
of
write
course,
book
of
or something.
course,
Okay,
of
Dr. Nora
course.
Wahida. Thank you so much. See you again. Thank you.
Thank you so much, Dr.
Thank
Azima.
you.